representing the periodic chart, the electronegativity and ionization energy goes up as you go up the chart and as you go to the right. And if you can remember that, then the radius is the atomic radius and the ionization radius goes in the opposite direction. It goes up when you go to the left and when you go down the chart. And you guys that are presenting will talk about why that is and quiz each other on whether or not you understand the concept. Okay, did we talk about francium and fluorine yesterday? Yes or no? No. Okay, so one way to remember the direction of those two elements, and especially if you're on the academic team. Who is on the academic team? Okay, so one question that comes up from time to time is what is the highest and lowest electronegativity? So you all should know that francium has the lowest electronegativity and the lowest ionization energy, and fluorine has the highest electronegativity and the highest ionization energy. So if you can remember that, then you'll have the trend lines going in the right direction. Okay, so at this point, as you give explanations, write, some people are going to do some basic stuff. Write the basic stuff. You can't write every single thought. We'll be rewriting the entire section, and the bulk will never get through in time. We have half the period to get through this, and the other half for the quiz. So let's start with atomic radius. Atomic radius. People, could you come forward? Does it feel okay, better or worse when we have the lights off?
Worse.
Worse. Okay, so you guys will just have to do it this way. Okay, speak real loud so that Jessica can hear you.
We have atomic radius, and for metals, the atomic radius is defined as half the distance between the adjacent nuclei and the crystal of the element, and it's shown right there. That's the radius.
For elements that commonly occur as molecules, which are many nonmetals, the atomic radius is defined as half the distance between the nuclei of identical atoms that are chemically bonded together.
We don't have to write down every definition. You've got the idea. You look at the center of the nucleus, get the distance, and you divide it by 2, and that'll give you the size of the radius.
Trends within the period caused by increasing positive charge in the nucleus and the fact that the principal energy level within a period remains the same, and the result is the increased nuclear charge puts the outermost electrons closer to the nucleus. Trends with groups, the outermost orbital increases in size along with the increasing size. This means the atom is larger. The larger orbital means the outer electrons are farther from the nucleus. The
class interpret what that means. It's a lot of chemistry speak. What in the heck does that mean? Can anyone interpret that? What is that? Either one. That, as you go across a period, you have increased nuclear charge. What are they talking about? You guys are, you're not on the spot, we're putting your place on the spot. So as you go across a period, you've got increased nuclear charge. Remember the magnets, so that means it's pulling it in, but what are they talking about? Increased nuclear charge. Where is that coming from? Anna?
The relationship between the protons and the electrons and the electrostatic repulsion to them.
Okay, in this case, attraction, because you got positive, but why is the nuclear charge increasing? Why are they saying?
Because the protons are increasing.
Because the protons are increasing. So you have, 2, 3, 4, 5, 6, 7, 8, 9 protons. So essentially you're getting a stronger and stronger magnet. It's not a magnet, we're talking about electrostatic forces. But you've got this stronger force that's pulling it in, it's sucking the radius in. Because the radius is created by the negative charge. So I love your vocabulary that electrostatic charge is pulling in it. Okay, good job. Deb, are you going to quiz us on this? Do you have any questions, or do you want me to do the quizzing? Okay.
What is the trend of atomic radii as you move down a group?
Like the chart.
Decreases. My bad.
And what is the trend of atomic radii as you move across the period?
Which way?
Decreases.
Left, right.
That's right. Okay, so that increases.
Increases. Decreases, okay. I don't know.
That's right.
Okay. Never mind, I lied.
So the best way to think of this is just remember one line. Remember the direction in which it increases. And then if you're asked what direction is it decreasing, you're gonna have to kind of think of it backwards. If you try to remember two lines, it's gonna get all mixed up. You've got enough trends to try to remember. So, did you have some more questions? Or?
No, that was
Okay, let me go ahead, you can sit down now. Let me give you a few quizzes. So we said it's sucking them in this way. So when you go this way, they're getting bigger. When you go down the chart, you're adding shells. You're adding layer and layer and layer and layer of electrons. So it makes sense that it's going to be larger, right? Because you're adding layers. So with that kind of picture in your mind, which one is larger, barium or calcium?
Barium.
Barium. As you go down, you're adding layers, and it's getting bigger. Which one's larger, nitrogen or bismuth? Which one, yes, which one's larger, mercury or zinc?
Mercury.
Okay, now let's do the cross the trend. Which one's bigger, sodium or fluorine?
Fluorine.
Sorry, I meant lithium or fluorine?
Fluorine.
Lithium. Fluorine has more charge, it's sucking those electrons in. That's always the harder trend to remember. And which one's larger, arsenic or gallium?
Gallium.
Which one's larger, calcium or potassium?
Potassium.
Which one's larger, iodine or rubidium?
Rubidium.
Okay, you got the trend? Yeah, one more. Which one's bigger, carbon or tin? Tin. Bigger going down, we're adding layers. Because bigger this way, you've got less nuclear charge. All right, good. Ionization, or